In this lesson, we're going to be learning how to calculate the empirical formula and the molecular formula of a compound. Let's start with this question. We're given, find the empirical formula of a compound containing 28.6% of magnesium, 14.3% of carbon, and 57.1% of oxygen. Then we're given the following atomic mass. Then for magnesium, the atomic mass is equal to 24 U, and then for oxygen, the atomic mass is equal to 16, and then for carbon, the atomic mass is equal to 12 U. So let's start with the solution. Now the first step is to write out these given percentages. So we're given magnesium has 28.6%, then carbon has 14.3%, and then oxygen has 57.1%. So let's sum these percentages given and know if is up to 100. So the total percentage is going to be 28.6 plus 14.3 plus 57.1. So if you calculate this, you see that all of them are equals to 100%. So having done that, let's go ahead and calculate the empirical formula of this compound. So we have magnesium, we have carbon, and then oxygen. So let's write out their percentages. So this one is 28.6, this one is 14.3, and this one is 57.1. So the next step is to divide each of these percentages with their respective atomic mass of their elements. So for this magnesium, the atomic mass is 24. So we're going to divide this 28.6 by 24. We're going to divide this 14.3, which is of carbon, with 12, and then divide this 57.1 of oxygen with 16. So 28.6 divided by 24 is equal to 1.192. 14.3 divided by 12 is equal to 1.192. Then 57.1 divided by 16 is equal to 3.569. The next step is to divide through by the smallest percentage atomic ratio. So in this case is 1.192. So we're going to divide by 1.192. I'm going to divide by 1.192, and then divide again by 1.192. So this over this will give us 1, then this over this will give us 1, and then 3.569 over 1.192 will give us 3. So the empirical formula of this compound is magnesium with 1 atom, then carbon with 1 atom, which is this one here. Magnesium is 1 atom, then oxygen with 3 atoms. So since magnesium and carbon are 1 atom and 1 atom, there's no need indicating it as 1 1. So let's just write it as Mg, then CO3, and then this is the empirical formula of this compound. Question number 2. A compound on analysis gave the following compositions: potassium 26.57%, chromium 35.36%. What is its empirical formula? So the first step is to sum the total percentages and know if it is up to 100. So total percentage is equal to 26.57, then plus 35.36. So this is equal to 61.86, which is not equal to 100%. So to get the remaining percentage, we are going to subtract 61.86 from 100. So 100 minus 61.86. So this is going to give us 38.14%. But which element has this 38.14%? So that element is equal to oxygen. Now this is because most of the compounds that have been analyzed are oxides. So each time the total percentage is not up to 100, you assume the remaining percentage to belong to oxygen. So having found the remaining percentage, let's go ahead and calculate the empirical formula of this compound. So we're given potassium, which is K, then chromium, which is Cr, and then we have oxygen here. The percentage of potassium is equal to 26.57. We have 26.57. Then that of chromium is equal to 35.36. We have 35.36. And then for oxygen is 38.14. This is 38.14. The next step is to divide them by their atomic masses. So the atomic mass of potassium is equal to 39. That of chromium is equal to 52. And then that of oxygen is equal to 16. So 26.57 divided by 39 is going to give us 0.679. 35.36 divided by 52 is going to give us 0.680. And then 38.14 divided by 16 is going to give us. So the next step is to divide by the smallest number here. So the smallest here is 0.679. So we're going to divide by 0.679, divide by 0.679, and then divide by 0.679. This over this will give us 1. Then 0.680 over 0.679 is going to give us approximately 1. And 0.679 is going to give us 3.5. So the question now is, are we going to round up this 3.5 to 4? So the answer is no. We are not going to round up this 3.5 to 4. Rather, we are going to multiply everything here by 2. Alright, so that we reduce this 3.5 to a whole number. So 1 times 2 is equals to 2. Then 1 times 2 is equals to 2. And then 3.5 times 2 is equals to 7. So the empirical formula of this compound is K2, then chromium 2, and then oxygen, then this is 7. So this is the empirical formula of this compound. Now if you are solving this empirical formula and you get to this point, now anytime you have 0.1 then 0.2, you are going to round off to the nearest whole number. Alright, so you are going to round off. If you have 0.3, 0.4, 0.5 and 0.6, you are not going to round off. Now if you have 0.3 and 0.4, you are going to multiply by 3. And then if you have 0.5 and 0.6, you multiply all through by 2. So this will reduce them to a nearest whole number. Then if you have something like 0.7, 0.8 and 0.9, then you can round it off to the nearest whole number. Now remember, we are going to multiply all of these by any of these 3 or 2 depending on the answer you got. So it's not going to be only the one that is affected you are going to multiply. It's going to affect everything here. Question number 3. Quantitative analysis shows that the empirical formula of a compound is CH. The molecular mass is found to be 78. Then what is the molecular formula of the compound? So solution, we have already been given the empirical formula of the compound. So we have to find the molecular formula of the compound. Now know that molecular formula is equals to empirical formula multiplied by N. Now where N is equals to the molar mass of the compound over the empirical formula mass. So this is empirical formula mass of the compound. Now the molecular formula is what we are asked to find. We already know the empirical formula mass. We are going to get it from this. So let's find N. So N is the molar mass, which is given as 78. So N is equals to molar mass is given as 78 over empirical formula mass. So the empirical formula mass of DCH, so this is equals to DC is carbon with 12 atomic mass, then plus H, which has atomic mass of 1. So this is equals to 78 over 12 plus 1 is 13. So 78 over 13 is equals to 6. So the molecular formula of this compound is equals to the empirical formula, which is equals to, we are given as CH, then multiplied by N, which is equals to 6. Remember, we're going to multiply this 6 by the atoms of this element. So this is going to be equals to, the atom of this carbon is 1. 1 times 6 is 6. So this is C6. Then H, the atom of this H is 1. So 1 times 6 is H6. So this is as in typical benzene. So this is the molecular formula of this compound. Thank you for watching. Please remember to subscribe to my YouTube channel. Turn on the post notification bell so that each time I post a new video, you'll be the first to watch it.